Hello, everyone. Thank you very much for joining us this afternoon for this talk. I'm extremely pleased to introduce Peter Hedenskog, who is actually just joined the performance team yesterday. Peter is a very experienced web performance engineer. He runs the Web Performance Meetup in Stockholm, Sweden. And is the creator of several popular and highly useful open source tools for analyzing web performance, chief among which is sitespeed.io, which has gained quite a lot of traction and publicity recently. Peter is going to be talking about web performance, unsurprisingly. So without further ado, I'll pass it over to him.
No, it works, right? Yeah, okay. Perfect. So my name is Peter. It's me when I was little. I'm from Sweden, you know. And you know Sweden, right? ABBA. Yeah. And I'm from a small town called Uppsala. And in the HBO series called The Vikings, this is actually Uppsala. But it doesn't look like that, really. But it's quite cool, right? It looks something like this, the old place, Uppsala. And I'm from Sweden, and in Sweden we have one really, really cool thing. We have the Twitter account Sweden. Do you know about it? So each week, a new user will have the account of Sweden, a Swede, and will talk about Sweden. And this week, you know, Luis is talking about San Francisco from a Swede's point of view. So that's kind of cool, I think. And the last thing about Sweden, we are really good explaining things in pictures, right? You know that? So let's see how I will do today. I've been working with web performance for quite a while. I've been helping different companies to become faster. And one thing that is really, really, really super important, and I think you know already, you've seen this, right? The Maslow's hierarchy of needs. And you see that down below, we have fast websites. It's super, super important. And you all know that, so that's really, really good. Yeah, one thing. You can pop me a question whenever you need, whenever you feel something that you want to question me about. So just do it. So we know that fast websites is really super important, right? And one thing that not everyone knows, I think you know, but maybe not everyone, it is the speed happens in the front end, right? And it was like this. There's a guy, like the godfather of web performance, called Steve Souders, that did a study many years ago where he tested the websites. I think it was top 50,000 websites, and compared how much time is spent in the front end and how much time is spent in the back end for a user. Yeah, and his summary was that 80 to 90% of the time is spent in the front end. So it's really important how we create our front end. And he called it the performance golden rule. So it is not that 80 to 90% of the end user response time is spent in the back end. No, it's in the front end, right? And what does that mean to us with Wikipedia? So, have you seen this before? Do you know what it is? No? Okay, so it's a waterfall graph. It describes how the browser is actually loading all the assets of a page. So what happens first is that it loads the HTML page, and then it starts to go through all different assets that are going to be loaded on the page. All the images, all the slide sheets, all the JavaScripts, right? So I did a couple of red things on the top. I don't know if you see them. I'm trying to explain what is backend and what is frontend. So the first one, you see the first request to the main page, the small one, that's actually the backend, when we generate or send out the HTML. All the other things to the green line in this example is when we actually put something on the screen for the end user. And the blue line there is when we do the onload event is happening. So in the old study that Steve Souders did, he waited on the onload to happen, but for us, it's probably better to compare with our first paint. And for us, that is, yeah, maybe 15, 20% spent in the back end, and the rest spent in the front end, right? Yeah. This is just an image explaining how the actual page is displayed by the browser for Wikipedia. And that's cool. If you see, it takes, in this example, when I tested it, it takes a little bit over 1.2 seconds. But then we almost display 90% of the page. So it happens like mine. So we know that it's really important with the front end, right? So what does that mean to us front end developers? Do you know? We have the power, right? We can make things happen. We are stronger than Pippi Longstocking. When we do things, we can make things happen. We can make pages really, really fast for the end user. Yeah, we have really, really power. But when we have great power, you know, yeah, perfect, thanks. We need to have responsibility, yeah. So we need to understand how the browsers work. And I think you already know this, but I'm going to repeat it because it's really, really good to know how it works. So we need to understand how a browser renders a page, because if we understand that, then we can make sure that we deliver the content in a good way so that the browser will display the content really, really fast for the end user. Okay, so it happens like this. You know, when you type in the URL in the browser window, and you click return, the browser will first guess the HTML. And when it gets the HTML, the browser needs to create a document object model that's displaying what kind of tags we have on the page and how it looks like. But to be actually be able to display something, we also need the style sheets, right? So in the best case scenario, we got the HTML, we download or inline the CSS, we can create the CSS object model, and we can merge them to the render tree. And when we have the render tree, we can put out the layout and paint the page on the browser, right? It's super simple. But you usually have one problem, and that's JavaScript. And it works like this. You know, in JavaScript, you have the ability to change the document object model with the document right. So if you load the JavaScript synchronously, that you usually do, you will tell the browser, okay, you have the ability to change the document object model. So until we have loaded all the JavaScripts and run them, we can, when that is finished, we can create a document object model. So if we just include the JavaScript the old standard way, we know that we need to wait until the JavaScript is loaded until we can create the DOM, and we cannot display anything before we have created the DOM and created the CSS object model, because then we can create a render tree. And then JavaScript can also look into the CSS, right? You can check what kind of layout you have and so on. So JavaScript is waiting on the CSS. That's the old thing that, you know, I forgot to mention it, but I think you know that already. The old Wieslow rules that Steve Souders created. It's a bunch of rules that tells what kind of rules we need to follow to make a page load really fast. And in that, these rules was that one of the rules is that you need to load JavaScript at the bottom of the page. That's because you want to have the CSS load as fast as possible to generate the CSS, and then you can execute the JavaScript. Instead of loading the JavaScript on top, you know that the browser will need to wait to execute the JavaScript until the CSS is loaded. Am I right, Ori? Yeah. Okay. So, but there's a trick, you know. If you tell the browser to load the JavaScript asynchronously, you will tell the browser that I will not change the document object model with the JavaScript. So it's a rule. So if you if you load the JavaScript asynchronously, you will not change the document object model. And that's what the changes we have done now in Wikipedia. Okay. So, you know the document object model and the CSS, and one cool thing, just to visualize it, you know how these are different HTML tags, but you maybe have seen it before in Firefox. So you can see how deep is your page, because you know you have the CSS and you have the HTML, and the browser need to merge it together. And when it merges it, the smaller your document object module is, the easier it is for the browser to actually merge the page. So if you create a page for example, if you have a page on a mobile browser, and the mobile browser has very little CPU, it's good to try to have the styles or have the object model as flat as possible. So we know that we need the CSS and the HTML to generate the page, right? But then we also have one thing called the look-ahead pre-parser. Each browser has it, and what it does, it's go through when you download the HTML, the browser has the HTML, and before it starts executing anything, it will have a thread that will go through each and every line and trying to find object that the browser knows that will be important to the page and start download it, right? So for example, each browser knows that if you put JavaScript inside of head, it will block. So it will try to find this and try to start downloading it as fast as possible. Also, if you have important images or whatever, it will try to find these kind of things as fast as possible and start downloading it. And each and every browser has its own implementation of the look-ahead parser. So it could be that Internet Explorer looks for one thing and prioritizes one thing, Chrome prioritizes another thing, and so on. So it's really important to try in different browsers, because different browsers will download assets in different orders. And the look-ahead parser will look for objects that are like the standard way of doing things. So for example, if you have an image source tag, if you have a JavaScript tag, or if you have a CSS tag, it will look for these kind of objects and download it, right? So I have an example here of a page that looks like this. So we have a big image there first, and then you have a couple of small images, and yeah, you have a couple of Twitter and LinkedIn logos. And this is how the browser actually downloads it, and I will explain soon. So you see it will start with a couple of images, and then it will take all the different images that are from the logos, and then almost at the end, it was actually download the big images that we had first on the page. And this happens because of the look-ahead parser. So it will go through the HTML on this page and try to find things. Okay, what is important for this page? The only thing, if I have built this page, I would say, okay, the main picture at the top is the most important picture, right? So we want the browser to download it as fast as possible. So if you check the HTML, this is actually the image that they download. But you see, it's not a regular image tag, right? They have a JavaScript that will hook in. When the JavaScript is executing, they will start downloading the image. So this is like the big image in front. So we have built, in this case, we have built something that breaks the look-ahead parser, because the look-ahead parser don't know that this is actually an image that we can download, because it's not a regular image source tag, right? So instead, it will start download all the images that are real image tags. So for example, you see that the logos here down below, almost at the end of the page, are downloaded much faster than the big hero image, right? And that's because these images are regular image tags, so it will be found by the look-ahead parser, and the other two images there on top or not. Yep. So we can be really nice to the browsers to tell them use standard HTML to make it easy for look at parser download things, and we need to parse them. And then we have one third thing that is really important, and that's with the performance view is for mobile browsers, where you have proxy browsers. And there's two kinds of proxy browsers, right? So we have the best practice proxy. So that's really, really easy. So we have, we have a couple of rules that will make the web page really fast. We need to compress content. We can create we can combine images, etc. So in the mobile world, we have these kind of proxies that do all the kind of best practice rules. So when you surf on your mobile, you will access the URL, and the proxy browser or the proxy will collect the data from the server and do all the best practice rules and send it back to the end user, so that the mobile browser have less data to take care of, and it's can generate the page faster, right? And from a performance engineer perspective, that's quite hard, because we don't know exactly what they will do, but we will talk about more about that later. So we have the best practice proxy, and then we have the distributed remote browser. That's really, really hard to understand or to measure. The thing is, the first example, then we send the HTML, the JavaScript, and the style sheets to the browser, but we fix it a little to make it faster. In the distributed browser world, we actually execute all the thing on the server side, and then have our own protocol and send over whatever data we want to the browser. So, for example, if you are in a country where you have only a 2G connection, and you have an old phone, it could be better that you have our own protocol where we send only the data that will show on the screen. And that's really hard for us to actually see what is happening and understand if it's fast or not, because that is happening all on the browser side. Yeah. Okay. So we know now that it's really important to understand how the browser is working, right? So, and we have a couple of best practice rules today, how we actually should do to deliver the content as fast as possible to the end user. So how do we make the pages super fast? And one thing that everyone talks about today is above the fold. So, a lot of pages are really, really long, right? And you deliver all the content to the browser, and the browser starts to render it. But what's important to the end user is the thing that you actually see on the screen, right? The above the fold content. So in best case scenario, we should try to aim to give the CSS and the HTML and the images that we need to start to render the content above the fold, right? So if we have a way of prioritize it, we should start with that first. So what people do is they inline the CSS, and that's good for mobile phones, for example, when every request costs something extra. And then they asynchronously load the rest of the style sheets later. Okay. So we know how the browser will create the page, right? And we know that we also want to measure and keep track of a page and how we do that. So one thing that I really like is performance regression test. And that is to jack in something in your continuous integration to make sure that you keep track of the performance over time. Have you heard about the story or the fairy tale about the emperor's new clothes? Anyone? No? I can tell it. So there was a fancy emperor in the old days that really liked clothes, and he wanted to look really, really good, right? And there were people that trying to, they want to outsmart him and said, okay, we have really, really, really fine clothes, and it's super, super expensive. And the thing with the clothes is that if you buy them, only people that are really smart will see them, right? So stupid people will not see the clothes. They will think you are naked, right? So that's the emperor. And of course, all the people in the country wanted to be smart, right? You don't want to send out and be stupid. So they said, oh, emperor, you have so fine clothes. It's really, really great, right? But one day, there was a kid that actually saw the emperor and said, oh, the emperor has no clothes, right? And that's our web performance tool that we have in the continuous integration. We need to have that to tell us when things are going bad. And preferably, if we can do it before we do a release. But at least so we can keep track of things when we do commits and so on. And it could be like we can do it, depending on the system we have, every commit, or once an hour, once a day, or something like that. It depends. So there are 3 ways of keeping track of performance, or like the best practice way of doing it today. The first one is to do it in the continuous integration, right? The second one is that we do today. That's really cool, that we collect data from the users using RUM, real user measurement. So in the browsers from the users, we beacon back data, how fast the page are to our servers. The thing is, it's really good for us to do that, to keep track of things over time, and that's perfect. But it's hard, or at least I think it's hard to actually pinpoint real problems. Because we can see trends and see if we are going faster or going slower. That's really good. But all the different users has different latency and hardware and connection types, so it's hard to actually say what's wrong, but we can see trends over time. So that's good. But to be able to more pinpoint what is wrong and what we should change, we can do something called synthetic testing. And that is actually running a browser in a controlled environment and testing performance. So we test one page or many pages. And it's good to actually test with different browsers because, as I said before, different browsers has different implementations. So we don't know if our HTML and our JavaScript and our CSS will be fast in this browser. So this is an example from a site that actually was using Google Ad Service. And you see there on line 7,726, they are loading the JavaScript, all following the YSlow rules, putting the JavaScript synchronously late, right? But in some browsers, I don't know which browser, you see that actually the second request that the browser do when they load the page is actually collecting the Google Ad Server JavaScript. So each and every browser will prioritize in their own way what they want to load, right? So it's important to test with different browsers to know how our pages are doing in different browsers. And the next thing is, it's good to test a couple of pages, our most important pages, because it can be hard to find things or to keep track of many pages, but it's also good to kind of trying to crawl page and try to find pages that ordinary users had edited and added data to, because I don't know which site, but one site had a picture of a sausage with 14 megabytes that a content editor has uploaded. So it's important, and the only way to find that was that doing actually testing in production, because the content manager could only add content in production, and so that's why we need to test things in production, find things if we have like, bad content. Okay. So we know we take the browser and we parse the HTML and the JavaScript and CSS, and we want to test before we release, preferably, and we want to test the data or the page in production. But what kind of metrics do we want to test, right? because we want to know if the page feels fast. And that's really, really hard, right? But that's the thing that is really important, because if the user feels that the page is fast, then it is fast. So what we want to do is we want to measure above the fold content. When is the content that are visible to the end user in the browser window, finished? So the end user can start reading it. So we need to find a way of measuring it. And the browsers today have a couple of different APIs that we can use. So we have the navigation timing API that we use today. And here you can see what kind of browsers that actually support it. And the navigation timing API tells us things like, okay, now the JavaScript, all the JavaScript of the page is parsed. The CSS object model is finished. But it's from the whole page. It doesn't give us any information about the above the fold content. It's still quite good, because you see a lot of browsers support it, and we can collect data and we can see things over time. And then we have the user timing API. That's another API that we can use, that we actually can create our own metrics. So, for example, we can add the timing on each and every page when something is happening. So, for example, when our first image has loaded, because nothing else supports it, and we can make it. We can add the JavaScript to actually collect the data and let the browser report it. You see, and that's good, because then we can kind of think of things that are important to the end user, maybe our logo or some images or something like that. But still, you see, not every supported browser supports it, not Safari. And then we have the resource timing API. And the resource timing API is telling us things like when are each and every resource on a page loaded, right? So we can find out when the JavaScript is loaded, different JavaScripts, different style sheets, and different images. And that's good, because then we have the whole picture of when the page is loaded. But still, the browser cannot give us the information on when is actual the browser windows finished above the full content. So we have a couple of different things in the browsers that are really good that we can use to collect timings, but we don't have the really, really good stuff that we need, right? Because we want to measure when the things that the people see are finished. So, and then we have the speed index. And that's a thing that was created by Pat Meenan for web page test. It's a tool that can measure things. And the speed index will measure when a page above the fold content is actually loaded. So you will get a number that says, say, in milliseconds when the above the fold content is loaded. And the way they do that is that they create a video of the page load, and then analyze it when it's finished and when it starts to load. And what's really cool about it is that if I have two different pages that are finished at the same time, if a page actually are delivering content before the other page, so you see things much faster than the other page, you will have a lower speed index. So it's also good that you can see things. You will get a better number if you deliver content really, really fast to the end user. And you have probably seen this before, yeah. So what they do, they analyze a video of the page when it's loaded, and then they can give us a number. What's good about it is that we have a tool that we can get that number. The bad about it is that it's only in one tool, right? So we cannot get it from our real users, and it's hard to combine with other things. But at least we have a tool that we can find out measure things. Okay, but metrics is not the only thing, right? So we have the numbers, but do the numbers really tell a real story? No. It depends on the context of the user, right? You know this guy? It's a Swedish prince, Prince Daniel. So you see here, he's got his fighting face on. He's going to play basketball, right? Normally it looks like this. Really fine, glad, happy people. but he's got his fighting face on. And depending on the context, right? So for an end user, if I surf a couple of pages, I will compare the page I'm on right now with other pages. So if I'm really fast, I must be faster than, or at least the same speed as the couple of other pages that I've been using the last couple of minutes or something like that, right? So it depends on what kind of context the end user is. And in this example, since Daniel is actually playing basketball with a kid, but it still has its fighting face on, and that's quite cool. Okay, so I'm actually at the summary, right? If someone has questions, we can take it, or you can take it after. So there's 3 really important things that we need to remember, right? This is how the pages are created, and it's painted on the screen. So, and I think you already know that, right? Yeah, maybe. So the HTML need to create a document object model, right? The CSS need to be a CSS object model, and then we parse it together to a render tree, and then the browser can start painting it, right? So we need to minimize the time until we can start creating the render tree, and create the layout, and create the paint. And then we have the look-ahead parser, right? So something in the browser, we start to look for things and try to download it as fast as possible. And we need to make sure that we do things in a good way so the look-ahead parser can find them. And the last thing is, there is no magic metric we can use, right? We have a lot of different metrics in the browser today. We had a navigation timing API, and that it's good, but it's not perfect. So we need to combine the metrics we have, use tools, and use the metrics in the browsers. And then we can find at least a quite good way to measure things. Yep. So do we have any questions? Crystal clear, right?
Hi, I had a couple of questions. It used to be where there were companies that you would pay them and they would sort of monitor the performance of your site from sort of all over the world. Do you think this RUM, I guess, real user monitoring, has that kind of replaced that, or is there still a role for paying some company to tell you how you're doing in Istanbul and how you're doing in?
So the companies that I have worked with have actually used like all the different tools to do that, because it's a different way. The real user measurement is good because then you collect data from the real users, right? But collecting data from different points in the world is good in a way because then you can keep track of is your content CDN provider is actually working, right? So most of the companies, or at least the largest one I've worked with, are using these kind of systems to make sure that the CDN providers that they use really deliver content in different places, right? So they use it in that way. Yeah.
So they use both.
Yeah.
I mean, because I guess the foundation has an advantage that we can sort of reliably assume we have users all over the world. We don't have, so I'm sure we get tons of data, but do you think there's still a role for those services?
So I think that kind of service is good to just keep track of things and how things are going, but to be able to understand how we can be better and how we can increase the performance of a web page, we need to put it on a lower level, because these kind of tools will not help us. So it's good to collect a real user measurement so we can keep track of things over time and keep the trends and see if we're going faster or going slower. But to be able to actually do things better, we need to have tools on our level, on our development environment and so on, and keep track of things. Because these kind of, like the keynote, maybe I shouldn't name names, but they are good, but they will not help us, I think. It's better to keep things at a developer level to see how things are doing.
Thanks. And my other question, well, it's more a kind of thing I've noticed. do you think there's a risk if you just focus on the time to paint above the fold? I've noticed on my phone there are a lot of sites where I'll see it, but I can't actually do anything. I'll be clicking buttons and nothing will happen. And even like, zoom gestures won't work. There's this kind of dead zone for like sometimes a long time. So I wonder if people are so focused on presenting that above the fold, and then the interaction is kind of completely screwed up for like 20 seconds.
Yeah, and that's what's important for us. I think we need to find the metrics that we think is really important on our pages, right? So we need to find, okay, maybe the about the full content is important, but we need to find the measurement that are important to us and to our users. So it's like, it could be that people are focusing like on the wrong thing, but for us, we need to make sure that what do we think is the right thing for our pages, and make sure that we can measure that, because it's really important to measure things that are really valuable to us, like call to action or something like that. So, and yeah.
Thanks.
Anything else? All right. Thank you so much, Peter.
Thank
That was
you.
great. Appreciate it.
Thank you.